Now, here's the answer. We already know that the marginal rate of substitution of this utility function is b over a. And this has to equal at the optimal point the price ratio PA over PB. We're interested how our quantity demanded of apples changes with the price of apples. So we keep the price of bananas fixed at 2. We plug that in, and equating that with the marginal rate of substitution, we arrive at an expression for the quantity of bananas and how it depends on the price of apples and the number of apples consumed in equilibrium. We plug this into the budget constraint in order to get rid of the b in the budget constraint, such that we are left with an expression only in the price of apples and the quantity of apples. And then we solve for the quantity of apples in order to arrive at the individual demand function for apples as a function of the price of apples. Having done that, we continue with section 5.3, where we decompose the response to a price change into the income effect and the substitution effect. And this is the deepest part of this lecture. And the key realization that you need to make is that when the price of a good changes, then actually two things happen. The relative prices of the goods, they change. So one good becomes relatively more expensive and the other one less. And the second effect is that your purchasing power increases. There's more that you can do with your money in case of a price decrease. In case of a price increase, your purchasing power decreases. There's less that you can do with your income. And in section 5.3, we're going to disentangle these two effects. So the substitution effect refers to the change in consumption choices due to a change in the relative prices. So this isolates the effect of the relative price change. And this is always non-positive, and in most cases it is negative. If the price of a good increases, then most often the quantity that you demand of that good decreases. You substitute away from the good that has become relatively more expensive. That happens in almost all cases. The second effect, the income effect, refers to the change in consumption choices due to the change in purchasing power. And this is actually the same as the income effect that we already studied in section 5.1. And this can be negative or positive, dependent on whether we study a normal good, where the impact is positive, an increase in income increases your quantity demanded for the good, but when the good is inferior, you decrease your consumption of that good following an income increase. And the total effect is just the sum of the substitution effect and the income effect. And we will run through quite a number of examples, but we start with apples and bananas. So what are the effects of a fall in the price of apples? So this is our original budget constraint. Now the price of apples drops, which means that the budget constraint pivots outward. So if we spend all our money on apples, we can now buy more apples than before. So this is the original optimal consumption bundle C with the original budget constraint. We consume 3 apples and 5 bananas. But now the price of apples drops and our budget constraint shifts or pivots outward as apples become cheaper. Again, we optimize. What is our optimal consumption bundle? The total effect is that now we will consume the bundle D, which contains 5 apples and 6 bananas. So we shift from bundle C to bundle D, and that is the total effect of the change in the price of apples. First, we're going to isolate the substitution effect. So decomposing means that we are going to dissect the total effect into the two components, the substitution effect and the income effect. And first we focus on the substitution effect. So we determine the bundle of goods that you choose at a new price and the new relative prices while maintaining the utility experienced before the price change. So in maintaining the same utility level just means that you stay on the same indifference curve associated with the utility that you already got. So what we do is that we shift the new budget constraint inward until it's tangent with the old indifference curve. So sounds complicated. In picture it's much easier. So we have the old budget constraint and the old indifference curve U1, and now we're going to account for the change in relative prices. So we're going to change the slope of the budget constraint, but we keep the utility at the original level. So we're going to pivot our budget constraint until it touches again on the old indifference curve. So, and then we arrive at this line, this budget constraint BC prime. So at this budget constraint, we are just as well off as before because we cannot reach a higher indifference curve. But the thing that has changed compared to the old budget constraint, the green one, is that the relative prices of the good 1 and 2 have adjusted and they are equal to the price ratio under the new budget constraint. So this BC prime budget constraint is parallel to the budget constraint after the price change. So it takes into account the price change, but it doesn't take into account the increase in purchasing power. So this isolates the substitution effect, and isolating that effect and working with this budget constraint BC prime allows us to consume the optimal bundle C prime. So given the new price ratio, given that apples have become relatively cheaper than bananas, we do shift our consumption bundle. Our optimal consumption used to contain 3 apples and 5 bananas, but now apples have become relatively cheaper, and as a consequence, we're going to consume a new bundle C prime, which contains 4 apples and only 3 bananas. So the change from bundle C to C prime is only due to the change in relative prices. So what we didn't do is to take into account the increase in purchasing power. So we forced this consumer to remain at the old indifference curve. Stated differently, the consumer is compensated for the change in real income. Now I put this compensated within quotation marks because this compensation in this case actually means we take away money from the consumer up till the point that he's not able to reach a higher indifference curve. So we force him to continue to choose a bundle C prime on the old indifference curve. And the resulting change from C to C prime is a substitution effect. But of course, in practice, what also happens is that the price change not only changes the relative prices, but also allows the consumer to actually consume a bundle at a higher indifference curve. And that is the income effect. And it is the result of that the budget constraint BC prime actually shifts outward to BC2. And this is the same as what would happen if you would have an old budget constraint and you would get an increase in income. That would also lead to a parallel shift of your budget constraint. Now, the same happens here if you move from BC prime to BC2. That is the effect of the increase in purchasing power, which allows you to go from bundle C prime to bundle D. So we've now isolated the total effect, moving from bundle C to bundle D, into the substitution effect and the income effect. And as you can see, in this case, changing the relative prices, making apples relatively cheaper, has a positive effect on the consumption of apples. So price down, consumption up. So that's what we call the negative relation, as is often the case. Bananas become relatively more expensive, so people substitute away from the good that has become relatively more expensive. And the income effect is positive for both goods. So you can see that because of the increase in purchasing power, the apple consumption goes from 4 to 5, and the banana consumption pulls back from 3 to 6. And this actually just proves that both apples and bananas at these levels of incomes are both normal goods. If income increases, the consumption of the goods increases as well. So to summarize, in decomposing the consumer response to price changes into the separate income and substitution effect, we take 3 steps. So first, we draw the new budget constraint and find the new optimal bundle. Comparing that to the old bundle gives you the total effect. Then we draw a line that is parallel to the new budget constraint, but tangent to the old indifference curve. You determine the optimal bundle on the old curve associated with this theoretical, because it's not observed in practice, theoretical budget constraint. Then you get the bundle C prime. And then the substitution effect simply is the difference between C and C prime, and the income effect, the difference in quantities between C prime and bundle D. Now, you may ask, what happens, what does this picture look like if we have an inferior good? What are the income effect and the substitution effect? Now, for an inferior good, we have the definition that if the income increases, the consumption of the inferior good must decrease. So what does it look like in this case? In the case of an inferior good, the income and the substitution effects are opposed, and we consider the case where a consumer chooses between bundles of steak and noodles, where noodles apparently are the inferior good and steak is the normal good. So that leads to the following picture. So the old budget constraint is equal to BC1, it's the green line, and we have a fall in the price of noodles. So the new budget constraint is BC2. And comparing the old consumption bundle with the new consumption bundle D, we see that the total effect for both noodles and steak is positive. The consumption of both increases. But does it also hold for the income and the substitution effect? Well, let's see. So this is the picture that we had. Same exercise as before. We take the new price ratio and take the budget constraint, the theoretical budget constraint that is tangent to the old indifference curve, and then determine the new optimal bundle A prime. Comparing the bundles A and A prime gives us the substitution effect, and we observe that the substitution effect, as is most often the case, is negative. So the relative price of noodles becomes lower, means that we consume more of it. Steak becomes relatively more expensive, so we substitute away from it. We consume less steak, and this is just as in our previous example. However, now we consider the income effect, and the income effect is equal to moving from the consumption bundle A prime to the consumption bundle B. And as you can see, consumption bundle B contains less noodles than consumption bundle A prime, whereas it contains more steak than bundle A prime. So what happened is that because of the increase in purchasing power, the income effect, and noodles being an inferior good, the income effect on the consumption of noodles is negative. We consume less noodles. However, because the substitution effect for noodles is larger than the negative income effect, the total effect is still positive. Another extreme example are given goods. Given goods are defined as goods for which the quantity demanded increases as the price increases. So here the total effect is negative. A decrease in price leads to less consumption of the good, unlike what we saw for noodles, and an increase in the price of the good leads to an increase in the consumption. So what does it look like? A given good must be an inferior good, because otherwise the impact can never be in this direction. And it's an inferior good for which the income effect outweighs, is larger than the substitution effect. And this results in a weird upward sloping demand curve. And this is pretty unusual, but it has been identified in some empirical papers. So the classical example is the potato famine in Ireland in the early 1800s, when the price of potatoes increased. People needed to get their calories. So the story then is that because the potatoes became so expensive and the ordinary diet of people consisted out of potatoes and a little bit of meat, but the meat, of course, is always expensive. But because the price of potatoes increased, people were forced to skip their consumption of meat and to consume more potatoes in order to get their calories. So this is the classic example where the story goes that because of this famine, the increase in the price of potato led to an increase in the demand for potatoes. Now, it's not that easy to get data from that era on an individual household level, but more recently papers have studied rice consumption in Southeast Asia, and they found similar effects. So there are instances where indeed goods are given goods. Now in picture it looks as follows. We have potatoes and meat, just like in the classic example. The total effect is negative. So the price of potatoes, assume that we do it the other way around. So the price of potatoes is high, but then decreases. Then the total effect is negative. The consumption of potatoes drops as a consequence of the price decrease of potatoes, because people have more money to spend on meat. And they will shift towards consuming more meat and less potatoes because of the high increase in their purchasing power. Now, know that in order for the income effect to outweigh the substitution effect, the income effect must be large. And one condition that needs to be satisfied is that the share of income that people spend on a particular good, for example potatoes, must be large. Because if people only spend a small fraction of their income on potatoes, the income effect will never outweigh the substitution effect. So given goods normally can only occur for goods that compose a large fraction of a household's expenditure share. And this brings us to the quiz. Figure it out, the effects of a price change. We have chips and crackers, and Monica eats chips and crackers. Her income is 20, the price of chips and crackers is $1 and $2 per bag. At these prices, she eats 16 bags of chips and 2 bags of crackers, so her consumption is at point A. And when the price of crackers falls from $2 to $1, Monica consumes 8 bags of chips and 12 bags of crackers. So in the figure, you see the total effect of the decrease in the price of crackers. Now, the question to you is, given this information, Why does the budget constraint rotate? Label the diagram and estimate the income and substitution effect for crackers and which one is larger. And then third, are crackers a normal good or an inferior good? And what about chips?